Hello friend, welcome to this session on time, speed and distance. This topic forms a key part of various quantitative aptitude or mathematical aptitude sections in competitive exams, and it requires a logical bent of mind to be able to solve these questions. We will discuss the various items in theory, various important concepts, formulae, and we will take up some leading examples and questions to make the key concepts totally clear. So let us get started with our study of time, speed and distance. Time, speed, distance. As I said, a very interesting topic. Let us assume that a car is moving from Delhi to Bombay. Delhi is a fixed point and Bombay is a fixed point, and this is a moving object that is traversing the distance from Delhi to Bombay. Three quantities arise: the time that this car will take to cover the distance from Delhi to Bombay, the distance itself, and the speed with which this object was moving. So let me draw a simple diagram to explain the relation between these three quantities. So here is Delhi and here is Mumbai. We have a car that is traveling this distance along this direction. Now, let us say that the distance from Delhi to Mumbai is D. This is the distance D. And let us say that the body is moving, that is the car. Here is our car. Seems to be a very modern car. Let me put a red light on top of it. A flashing red light is moving at the speed of S. And let us say that it takes a total time T to cover the entire distance. Now we know that speed of the object is always equal to distance upon time. So let me elaborate this formula to make it crystal clear. Speed of the body or the object is equal to distance covered by the object upon time taken to cover the distance. So as we know, we have written this as S is equal to D upon T. The fundamental assumption in this discussion so far is that the speed of the object was constant. It was moving at a fixed speed. However, this may not be so always. The object may cover different distances with different speeds, in which case we will say that the object has had a variable speed pattern. Anyway, we will come to that later. As of now, let us assume that the speed was constant. Once we have this formula, speed is equal to distance upon time, S is equal to D upon T with us, three very interesting relationships arise. So we have the primary formula with us, and now we will look at three important relationships. These are logical relationships and some questions can be solved directly using these relationships. So let us get into that. The basic formula we have with us is speed is equal to distance upon time. Okay? Now, I have already told you that this speed here, S, was fixed. It was not variable over this distance T, for which it took a time of T. So now let us see the three derivations. Okay. So here are our three derived relations. First, if speed is distance upon time, so this means that if distance covered is constant, then speed varies inversely as the time. Now, when distance covered is constant, then speed varies inversely as the time means that suppose Delhi to Bombay is being covered by three different objects. This distance, object A, object B, object C. Naturally, the distance is fixed. So whichever object, whichever car will have a higher speed will take lesser time. Hence, for a fixed distance, speed varies inversely as the time. I hope this is very clear. So this is our first relationship. For fixed distance, speed varies inversely as time. A very, very important logical relation which can be used to solve questions. Relation number 2. From the same formula we get time is equal to distance upon speed. So this means that if time taken is constant, then distance varies directly as the speed. Now let us say that the car was traveling from Delhi to Mumbai and then onwards from Mumbai to Bangalore. And if we say that the time taken by that car to cover the distance from Delhi to Bombay was the same as the time taken by that car to cover the distance from Mumbai to Bangalore, then the distance covered will be directly proportional to the speed. I hope this is very clear. So any object in fixed intervals of time will cover a distance which directly varies as its speed. I hope this is very clear. And the third example, distance is speed into time. All these are derived from the same basic formula. So that means that if speed of the object is constant, then distance traveled varies directly as the time. Now this is also very, very obvious. If that car under question is moving at a fixed speed, then it is very obvious that the distances that it can cover will vary directly as the time that it is going to take. So, my dear student, we now have three relations with us using the basic formula speed is equal to distance upon time. Take your time to understand these three logically because we will use them later to solve many questions. We discussed earlier the difference between uniform speed and variable speed. Let us again understand that at a greater length. Uniform speed. If an object covers equal distances in the same time intervals, then we say that the object has a uniform speed. Howsoever small those distances may be and howsoever small the time intervals may be. Whereas if this is not so, then we say that the object has a variable speed. Thus, if any object or a car, for example, or an ant or a space shuttle covers the same distances in different time intervals, then it is said to have variable speed. Now let us turn our attention to the units of measurements and the conversion between the various units of measurement for time, speed, and distance. Time can be measured in seconds, minutes, or hours. Seconds is denoted by S, minutes by MIN, and hours by HR or H. Distance can be measured in meters, M, kilometers, km, or miles. And naturally, speed will be meters per second, MPS, or kilometers per hour, kmph, or miles per hour, mph. So these are the units of measurement. One has to be extremely careful while solving questions regarding the units of measurement. Now let us focus on the conversion of these units, another very important aspect while trying to solve the question. Right, so we just saw that time can be measured in seconds, minutes, and hours. Similarly, we saw that distance can be measured in meters, kilometers, miles. And so naturally, speed can be measured in meters per second, MPS, kilometers per hour, kmph, or miles per hour, mph. Let us look at length on the conversion of units. 1 hour is equal to 60 minutes is equal to 60 into 60 seconds is equal to 3600 seconds. 1 kilometers is equal to 1000 meters is equal to 0.6214 miles. But 1 mile is equal to 1.609 kilometers. So that brings us to a very interesting relation that 8 kilometers is equal to 5 miles. You have to remember all this. 1 yard is 3 feet and 1 feet is 12 inches. 1 kilometers per hour is equal to 5 by 18 meters per second. Very, very important to be memorized. Now, how do we get it? Very simple. 1 kilometer per hour is equal to 5 by 18 meters per second can be derived by putting 1000 meters here in the numerator and 60 into 60 seconds in the denominator. When you solve it, you get 5 by 18 meters per second. So that means to convert kilometers to hour, just multiply it by 5 by 18 and you get meters per second. And to convert meter per second into kilometers per hour, just multiply the given value by 18 by 5 and meter per second will get converted to kmph. Similarly, 1 kilometer per hour will be equal to 5 by 8 miles per hour. So this means to convert kilometer per hour to miles per hour, multiply by 5 by 8, and to convert miles per hour to kilometers per hour, multiply by 8 by 5. I hope these conversions and these units are absolutely clear to us. Once this basic learning is through, we started with the definition of speed, distance upon time. We saw the 3 basic relations when distance, time and speed respectively will be constant. And then we saw uniform and variable speeds and then the various units and their conversion. So now it is time for us to get into concepts and questions. An important concept. If a man changes his speed in the ratio m:/n, then the ratio of times taken to cover that distance becomes n:/m. We know this from the original learning when distance is fixed. We know that speed varies inversely as the time taken. Hence, if a man changes his speed in the ratios m:/n in order to cover the same distance d, then the ratio of times taken will change to n:/m. Let us see a question based on this basic concept. So here is a question based on this simple concept. Let me read it out. Walking at 5/6 of his usual rate, a boy reaches his school 12 minutes late. Find the usual time to reach the school. Let us solve this question. Speed of the boy is 5/6 of his usual speed. So using the concept that we have just studied, we know that time taken by the boy will be 6 by 5 of the usual time taken, which basically means 6 by 5 of the usual time, which means 5 by 5 of the usual time, which means 1t, plus 1 by 5 of the usual time. So actually 1 by 5 of the usual time is the extra time that we are taking now, because our speed has gone down by 1/6. 5 by 6 is our speed, and that has resulted in this 1 by 5 of extra time that we are now taking to reach the school. So this means that reaching 12 minutes late is covered by 1 by 5t. This is the extra time we are taking. That's why we are late, and that late amount of late is 12 minutes. So this means that under normal circumstances, the time I would have taken would be 12 into 5, which is 60 minutes. Thus, when he goes at his usual speed, he takes 60 minutes to reach the school, hence solved. If you practice this properly, you can solve this question mentally. Speed has become 5/6, so time will become 6 by 5. 6 by 5 is 5 by 5 plus 1 by 5. 1 by 5 is 12, so 1 will be 12 into 5, 60. That's the answer. Can be solved mentally in 10 seconds with some practice. Let us see one more question on the same concept. Here is the second question. Walking at 13 by 11th of her usual rate, a girl takes 3 minutes less to reach her school. Find the usual time taken by the girl to reach the school. Let us solve this again. In fact, since we have already solved a question on this concept, can you solve this question mentally? Look at the screen. If she is going at 13 by 11th of her usual speed, it means the time taken will be 11 upon 13th of the usual time. That means 2 by 13th of the usual time less. That means 2 by 13 will be 3. So that means twice the time will be 39. So that means the regular time will be 39 by 2, which is 19.5 minutes. We have just solved it in less than 15 seconds. Let us write and solve. The speed is 13 by 11 of the usual speed. So this means that the time this girl is going to take, she's a very sincere girl, she's walking faster than usual. It seems there's an important class today or some exam. So the time she is going to take will be 11 upon 13th of the usual time. So this means 11 upon 13 of the usual time will be usual time minus 2 by 13th of the usual time. 13 by 13 is 1, that is t. So again, we reach the same logic that this increase of speed to 13 by 11 has led to a saving of time of 2 by 13t, just like the previous example. So 2 by 13th of the usual time taken was 3, because that's how early she reached, which can now be easily solved. So t is equal to 3 into 13 divided by 2, which will be 39 by 2, which is 19.5 minutes. So this means that she reached normally in 19.5 minutes. So what was the concept we have seen? We saw this basic concept here. If a man changes his speed in the ratio m is to n, then the times taken change in the ratio n is to m. And then we saw these two questions, question 1 and question 2, based on this concept. We can now move on to the next concept in time, speed and distance. Okay, we now move on to an interesting concept called average speed. Suppose a body moves from a point x to a point y at a speed of u. And the body then retraces this path from the point y to the point x at a speed v. If I now ask you, what is the average speed of the body for the entire journey? Perhaps you will say u plus v by 2, but that would be a wrong answer. The average speed has to be calculated from the first principles. Let us see how. We will then have a formula, a handy and a ready formula for use in all such questions. So as I said, here is a point x and here is a point y. A body moves between these 2 points, which are located d units apart. Let us say that the body, which can be a car or a man or a plane, covers the distance x to y at a speed of u, could be meters per second or kilometers per hour or miles per hour, doesn't matter as long as both sides is the same, and then retraces the same path at a speed of v. We now need to calculate the average speed for this entire exercise, this entire journey. So let us begin. We know that speed is equal to distance upon time. Distance traveled upon the time taken to travel that distance. This means that average speed for a journey will be the total distance traveled upon the total time taken to travel that distance. Now, if this is the case, then we know that the total distance traveled will be d plus d. X to y is d and y to x is d. And the total time taken is t1 plus t2. Now, what is t1? The time taken to go from x to y. Okay. But we know that time is distance upon speed. So, t1 will be d upon u. And by the same logic, t2 will be d upon v. So this will now help us calculate the average speed. In this formula, I just substitute and I get 2d upon d by u plus d by v is the average speed. So we will now simplify this. The moment I simplify this, I get average speed will be equal to 2d upon dv plus du. I will take uv to the top, d will be common, v plus u. I will simplify and the final answer is 2uv upon u plus v. So, the formula for average speed that we have just derived is equal to 2uv upon u plus v, where we know that u and v are the speeds with which a fixed distance has been traveled. So take a look at this derivation once again. And remember, this is average speed, which is the derived quantity. So u plus v by 2 will be a wrong way of calculating it. I hope this entire derivation is correct. And I also hope that you have understood the same logic can be extended to 3 legs of a journey or 4 or 5. It doesn't matter. Let us take up a question to understand this formula better. Okay, so here is the question. A farmer goes around an equilateral triangle-shaped field at speeds of x, y, and z kmph on the first, second, and third side respectively, and reaches back to the starting point. What's his average speed for the whole journey? Now we need to solve this very simple question using the understanding of average speed that we just developed. Let's have a look at the screen. This is the derivation of a formula. I hope you remember that. We just did it. So instead of a journey of 2 legs, I will now make it a journey of 3 legs. And the same derivation will help us. Here is the field, which is basically an equilateral triangle. Let me give ABC as the names to the vertices, that is the ends. Now because it is an equilateral triangle, the 3 sides are mutually equal. Let us say the length of each side is d units. Once again, it can be meters or kilometers, doesn't matter as long as all of them are in the same units. So you have d, d, d. It is given to us that the farmer moves along AB at a speed of x, along BC at a speed of y, and along CA at a speed of z. And now we are asked to calculate his average speed for the whole journey. So let us get started. Average speed of the whole journey would be total distance upon total time taken, d plus d plus d upon the total time. Let us say T1 plus T2 plus T3. But we know that speed is distance upon time. So naturally, time will be distance upon speed. Distance is d and the speed is x for the first leg of the journey and so on. So let me substitute this in the formula. So the average speed will be, so let us substitute these values in the step above, and we get average speed will be d plus d plus d, which will be 3d upon T1 plus T2 plus T3. But T1 we have just seen is d upon x, T2 we just saw is d by y, and T3 we have just seen is d by z. This is our denominator. So all we have to do is to simplify this, and after simplification, our final answer for average speed for this particular case will come out to be 3d upon xyz will be the denominator for this equation here, or this fraction here, and we will have dyz plus dxz plus dxy upon xyz. This horrible looking fraction is actually nothing because d gets cancelled out from the numerator and denominator, and xyz goes to the top. So you are left with 3xyz upon xy plus yz plus zx as the final answer. This is how this question is solved. Hence, average speed will be 2uv upon u plus v when we have two speeds under consideration, or 3uvw upon uv plus uw plus vw when we have three speeds under consideration. I hope this concept of average speed is absolutely clear, and the formulae can be used directly to solve any kind of question based on this. Let us move on to a fresh new concept. Okay, here is the new concept. If two persons start at the same time from 2 points A and B towards each other, so a person starting from A towards B and a person starting from B towards A at the same time, and after crossing each other, there will be some point at which they will meet, they cross each other, and after crossing each other, they take x and y hours in reaching B and A respectively. Then we have a formula that speed of the first upon speed of the second will be under root y by x. Here is the formula. So this is a special formula for a special case where these two were moving towards each other and they took x and y hours respectively to reach the opposite sides. Let us take a question to illustrate the usage of this simple concept and formula. Okay, here is the question. A man starts from B to K and another man starts from K to B at the same time. After passing each other, they complete their journeys in 3 integer 1 by 3 and 4 integer 4 by 5 hours respectively. If the speed of the first is 12 kilometers per hour, find the speed of the second man. Now it is very obvious that we can directly apply the formula that we have just studied. Speed of the first upon speed of the second is equal to under root y by x, where x and y are the times taken to reach the opposite end. So let's try to solve it. Solution. Speed of the first upon speed of the second will be under root 4 integer 4 by 5 divided by 3 integer 1 by 3. Let us simplify this further. This is the same as 24 by 5 divided by 10 by 3, which if simplified further is the same as 36 by 25 under root, which is the same as 6 by 5. But we know that the speed of the first man is 12. So 12 upon speed of the second man will be 6 by 5, which means speed of the second man, which is the unknown, which we are out to find, will be 12 into 5 by 6, which will be 60 by 6, which will be 10 kmph as the answer. So this is our answer, which we obtain by a direct application of the formula that we had studied here. I hope this formula and this illustrative example both are clear. Now you can very well ask me how this particular formula was derived. Would you be interested in quickly seeing the derivation of this formula? Okay, let me show you how this formula was derived in the first place. So we are out to derive the formula that we have just studied and used. So here is the point A and here is the point B. Let us say the first body moves from A to B at a speed of A. This is small a. And let us say the second body moves from B to A at a speed of B. This is small b. These are their speeds. Let us say they meet at a point in between at P. Let me take the whole distance as D, capital D, and let me say the distance from A to P is D1. So now we have to derive the formula that speed of the first body, which was moving from A to B at a speed of A, divided by speed of the second body, which was moving from B to A at a speed of B, will be equal to under root y by x, where y hours is the time it has taken to cover P to A, the second body, and x hours or x units of time, doesn't matter, is the time that this body took to cover the distance P to B. Very, very simple, and we will just solve it. When they meet at P, times are equal. The time taken to cover AP will be equal to time taken to cover BP because they have started at the same time, and when they meet, naturally their watches will show the same lapse of time. So this means that T1 is equal to T2 when they meet at P for the first time, which means D1 upon A will be equal to D minus D1 upon B. Okay, this is our first equation, which we can now rewrite as D1 upon D minus D1 is equal to A upon B. Let us just write it and keep it with us. Now, once they have met at P and they have moved on to their respective destinations, then we know that the time taken by the second body to cover the distance PA at the speed of B units will be D1 upon B, but this time is given to us as Y. I hope you know that. That was the statement. That was the original concept statement. And by the same logic, the time taken by the body to cover the distance PB at a speed of A will be equal to D minus D1 upon A, but that is given to us as X. Just divide this by this. So that gives us D1 upon B upon D minus D1 upon A is equal to Y by X. So this value of D1 upon D minus D1 can be directly used from here, equation 1. This is our second equation. So to simplify this, second equation is now rewritten as D1 into A upon D minus D1 into B is Y by X. But we know that the value of d1 upon d minus d1 is actually a by b. Just put that value here into this expression, substitute it. So that will give us a upon b into a upon p, this already exists here, will be y upon x. And this is precisely what we were looking for. So this now gives us a square upon b square is equal to y upon x, or speed of first upon speed of second is equal to under root of the times taken to cover that distance in the opposite directions. And this is our formula which we used on the last page, hence proved. I hope this derivation is completely clear to you. The reason I took up this derivation is conceptual clarity. You can derive any formula. For a competitive exam, it is advisable to remember formulae which can be applied directly. But not all questions will have direct applications. And so, my advice to you is to always be ready to derive anything quickly. It always helps. Let us move on to the next concept. Here is the concept. If a body moves at an average speed of v1 kmph to cover a distance of d kilometers without stopping, and moves at an average speed of v2 kmph to cover the same distance with stoppages, one or more, then the stoppage time per hour is given by v1 minus v2 upon v1. A very nice and elegant formula we have, with the help of which a certain type of question can be solved directly. Let us see one such question. Here is the question. A train travels at a speed of 60 kmph between two stations 240 km apart without stopping. It goes at an average speed of 40 kmph when it stops. What is the average stoppage time per hour? Let us solve it. Solution. When the train is moving at a speed of 60 kmph, it covers a distance of 240 kilometers. So obviously, the time taken to cover this entire distance will be distance upon speed, which is 240 upon 60, which is 4 hours. Now the same train, when it is moving at 40 kmph, covering the same distance, will now require 240 upon 40, which is equal to 6 hours. So it is very obvious that earlier I took 4 hours and now I am taking 6 hours. So the difference of these two times which have been taken, which is 2 hours, will be my total stoppage time. But this stoppage time has happened over a total time of how many hours? 6 hours. And so my answer has to be 2 by 6, which is 1 by 3 hours per hour is my stoppage time. This is the answer, which is 20 minutes per hour. I am stopping. Instead of solving it this way, if you wish to apply the formula that we have seen a little while ago, then you can apply it directly. Let us see. Using the formula, we get V1 minus V2 upon V1 as the answer. V1 is 60, V2 is 40, V1 is 60, which is 20 by 60, which is 1 by 3 hours per hour. Bingo, we have the right answer. So whichever way you wish to use it, do it. It won't take much time either ways. I hope that the concept and the illustrative question both are clear. So let us move on. Okay, now to revise everything that we have done, let us take a simple test of 10 questions which we will call quick questions. Here they are on the screen. Just take a quick look at the 10 questions and then we will take them up one by one. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So let us get started with the very first one. Question number 1. What's the length of a bridge which a man riding at 15 kilometers per hour can cross in 5 minutes? Now we know that distance is equal to speed into time. Now in this case, what are we asked to find? Distance, which is the length of that bridge. What is the speed given to us? 15 kmph, kilometers per hour. What is the time given to us? 5 minutes, which is 5 by 60 hours. So the moment I solve it, 15 and 64, 5 by 4, which is 1.25. And what will be the unit? Kilometers. Hence our answer is 1.25 kilometers. I hope this is clear. We come to question 2. Question 2 reads, Mukesh walks 10 kilometers in 5 hours. How much time will he take to travel 28 kilometers? Now speed of Mukesh is given to us as 10 by 5 kilometers per hour. 10 kilometers in 5 hour, distance upon time, that is speed, which is basically 2 kilometers per hour. How much time will he take to travel 28 kilometers per hour? 28 kilometers. So if 28 kilometers is the distance which he has to travel and the speed is already known to us, which is 2 kilometers per hour, so our answer will be 14. And what will be the unit? Hours. Because 28 was kilometers and 2 is kilometer per hour. So kilometers get cancelled, hour goes to the top and you have 14 hours as the answer. I hope this is very clear. We move on to question 3. Question 3 reads, if a cyclist covers 11 kilometers in 3 hours, so the speed is 11 by 3 kilometers per hour, find the distance covered in 5 hours. So we know very well that distance is speed into time. So here distance will be speed, which is 11 by 3 into time, which is 5. So our final answer will be 55 by 3 kilometers. Be very cautious about the units. There is no other problem otherwise. So the answer here is 55 by 3 kilometers. 11 by 3 was kilometers per hours and 5 was hours. Hours getting cancelled out. I hope this is clear. We move on to question 4. A man walks at 5 kilometers per hour for 6 hours and at 4 kilometers per hour for 12 hours. Find his average speed. Now your natural inclination will be to directly apply the formula 2uv upon u plus v, because that is what we have studied. But that would be wrong, because remember, in that formula, distance travelled was same. Distance travelled when we covered, the distance travelled when we went at a speed of u was the same as the distance travelled when we came back at a speed of v. Here, the distance itself is changing. So you have to go back to the first principles. Let us do that. At 5 kilometers per hour for 6 hours, how much will I cover? 30 kilometers. At 4 kilometers per hour for 12 hours, how much will I cover? 48 kilometers. So average speed will be total distance upon total time. This is the formula we use there also. So total distance will be 30 plus 48, which is 78, upon total time. Time is already known to us, 6 hours plus 12 hours. So our final answer is 78 upon 18, which is 13 by 3 kilometers per hour. I hope this question is very clear. We move on to question number 5. Question number 5. Walking at 3/4 of his usual rate, a man is 1.5 hours late. Find the usual time. We have already solved this question earlier. If I go at 3/4 of my speed, then it means the time I will take will be 4/3 of my usual time, which means I have taken 1/3 of usual time extra. and this is 1.5 hours. So the time, which is my usual time, will be 1.5 into 3, which is 4.5 hours is the answer. I hope this is very clear. We move on to question number 6. What's the ratio of speeds of two trains, one traveling at 45 km/h and another at 10 meters per second? Now, if you don't take care of the units, you're dead. So be very careful about units, okay? So the ratio would be 45 upon 10 meters per second. So convert it to kilometers per hour by multiplying it by 18/5. We have seen that. So 45 divided by 10 into 18/5. Once this is solved, it leads us finally to the answer, which is 5/4. I hope this is very clear. So the ratio of the speeds of these two trains is 5:4. Let's go on to question number 7. It reads, in a minute, how many poles will a railway passenger pass by if they are spaced 50 meters apart and the train speed is 60 kilometers per hour? Now it's a very, very simple question because it says that my speed is 60 kilometers per hour and there are poles, telephone poles for example, spaced 50 meters apart. So how many can I see in 1 minute going at this speed of 60 km/h? So 60 kilometers I cover in 1 hour. So 50 meters I'll cover in how much time? So first of all, let us just find the time taken to reach the first pole. So 50 meters is nothing but 0.05 kilometers. So at a speed of 60 kilometers which I cover in 1 hour, the time taken to cover 0.05 will be 0.05 upon 60 hours, which is the same as 5/6000 hours. Now this time 0.05 by 60 hours is the time taken to see one pole. So in 1 minute, how many poles will I see? So 0.05 by 60 hours was needed to cross the first pole, or was required to cross the first pole, or was able to show us the first pole. So in 1 minute, which is basically 1 by 60 hours, I will see how much? Very simple. 1 by 60 into 1 divided by 0.05 upon 60, which is the same as 20, which is our answer. So this passenger will be able to see 20 poles per minute if he travels, or rather the train in which he is sitting travels at the speed of 60 km/h. I hope this is clear. We move on to the next question, question number 8. Question 8 reads, a 200-meter long train is moving at 60 kilometers per hour. How long will it take to pass a pole? A straight pole has no length. So basically this question means that how long will this train moving at 60 kilometers per hour take to travel a distance of 200 meters? That means its own length, and in that duration it will cross that pole completely. So the answer is fairly simple. 60 kilometer I can cover in 1 hour. So 200 meters, which is 0.2 kilometers, I will cover in 0.2 upon 60 hours. So let us convert this into minute by multiplying it by 60. So I get 0.2 minutes. But 0.2 of a minute is 0.2 of 60 seconds. So our final answer is 12 seconds. So this train takes 12 seconds to cross that pole completely, which is equal to the time it takes to cover its own length of 200 meters. We move on to question number 9. A 180-meter long train, that's question 9, is moving at 54 km/h. How long will it take to pass a tunnel 720 meters long? So you have the total distance to be traveled by this train will be its own length plus the length of the tunnel. That is the time the train will take from the point the engine enters the tunnel to the point the last coach, the guard's coach for example, exits the tunnel. So the total distance to be traveled will be the length of the tunnel plus the length of the train, which is 180 plus 720 meters, which is 900 meters. So the question basically now becomes, how much time will a train traveling at 54 kmph take to travel a distance of 0.9 kilometers? So time is distance upon speed. So our answer is 0.9 upon 54. So 0.9 upon 54, if you solve it, this is 0.9 kilometers and 54 is kilometers per hour. So in hours, just convert it to minute multiplied by 60, 60 by 54, which is 10 by 9, this is 0.9. So that will give you 1 minute. And the answer to this question is 1 minute. Just simplify and you will get 1 minute as the answer. The last question of our quick question series, question number 10. Here it is. It reads, a train running at 30 meters per second takes 30 seconds to cross a platform 600 meters long. What's the length of the train? Very simple. So the solution is fairly simple. The platform is 600 meters long and let us say the train's length is x. So it is obvious that 600 meters plus x meters divided by, this is the total length or the distance that the train has traveled. Distance upon time will be speed. The time it took to cover this was 30 seconds. So 600 plus x meters upon 30 seconds is actually the speed of the train. That is 30 meters per second. So 30 into 30 is 900. So this will give you x will be equal to 900 minus 600, and that means the length of the train is nothing but 300 meters. So that takes care of all these 10 quick questions. Let's go through them once again. We saw these 10 questions, which was a very good revision of everything that we have studied so far. And before I move on to some leading questions again, you can now revise all these 10 and try practicing to solve these questions mentally. Okay, I hope this is clear. So let us now get down to some more questions. So here is a question. Ramesh travels 600 kilometers to reach home partly by train and the rest by car. He takes 8 hours if he travels 120 kilometers by train and the rest by car. But he would take 20 minutes more if he travels 200 kilometers by train and the rest by car. Find the speeds of the train and the car. And we have been given 4 options as well. Here is the solution. What is the total distance given to us? 600 kilometers to reach home partly by train and the rest by car. Now remember, the distance given to us is 600 kilometers and this is the distance to his home. So this is fixed. In the first case, he takes 8 hours and in the second case, he takes 20 minutes more. So that is 8 integer 1 by 3 hours, 8 hours and 20 minutes. So it is very obvious that the equations will be formed in terms of time. Now we know time is distance upon speed. So let us try to form the equation for the first condition. Partly by train and the rest by car. Let's say the speeds of the train and the car be x and y kmph respectively. So our first equation would be 120 upon x, this is the time taken when he travels by train, plus the balance is 480 by y because total is 600. So 120 gives you 480 by y will be equal to 8. I hope this is the first equation and this is clear to you. Similarly, 200 upon x, because in the question he says if he travels 200 kilometers by train, in that case the time taken to travel by train will be distance upon speed, which is 200 by x, plus 400 by y will be equal to 8 integer 1 by 3, which is 25 by 3. This is the second equation. I hope this equation is also very clear to you. Now we have to solve these two equations and we are given 4 options. If you are very smart working with options, one by one you can try to fit in the values using the options and see if things fit. Let us try the first option. Directly we will try to fit in the first option. X is 30 and y is 40. If I put 30 here in this equation and 40 here in this equation, I get 120 by 30, which will be 4, plus 480 by 40, which will be 12. So you have 4 plus 12, which is definitely not 8. So option 1 is wrong. Take option 2, 60 and 80. 120 by 60 is 2 and 480 by 80 is 6. 2 plus 6 is 8. The first equation is satisfied. So the answer is 2. You can also try the same values with second equation. 200 by 60 plus 400 by 80. And you will definitely get 25 by 3. So answer is option 2. In case you do not wish to work backwards from options, then let us try to solve these two equations. We will try and eliminate x from here. 120 and 1200. So the LCM will be, and 200, sorry. So the LCM will be 1200. So let us multiply the first equation by 10 and let us multiply the second equation by 6. So the moment I multiply the first equation by 12 and the second equation by 6, I get 1200 by x plus 4800 by y is equal to 80. And the second equation multiplied by 6 gives me 1200 by x plus 2400 by y will be equal to 50. I hope this is very clear to you. Now we have to solve these two equations. Just subtract, and the moment you subtract, this directly get cancelled out. And here you are left with 2400 by y is equal to 30. And so y will be 24 upon 30, which is equal to 80, which is what the option number 2 gives you. So you don't need to calculate for option the speed of x because it's 60. Just look at the option and get it. Hence our final answers are x is equal to 60 and y is equal to 80. I hope this solution is very clear. You can once again have a look at the complete solution here. This is a good question and we have seen how to solve the question working backwards from the options as well as working directly using the two equations. I hope this is very clear to you. Now we move on to the next question. Excluding stoppages, the speed of a mobile is 63 kilometers per hour and including stoppages, it is 36 kmph. The number of minutes per hour for which the mobile stops is. Here is the solution. Initially, the speed of the bike was 63 kmph and later on the speed of the bike became 36 kmph. Here, there were no stoppages and here there were stoppages. So this means that if I take the difference, this is the distance in kilometers which is covered extra when I am moving at this speed. So the difference being 27 kilometers, this is the distance which is covered extra when I do not stop. So it is very obvious that the time for stoppage is equal to the time in which I cover 27 kilometers at the speed of 63 kmph. This equation will give us the final answer. So it's very obvious. 63 kilometers I cover in 60 minutes. So 27 kilometers I will cover in how many minutes? 27 into 60 upon 63, and the answer here comes out approximately 25.71 minutes, which is option number 1. The options are very close, so approximation would be difficult. So we have solved it and we have got 25.71 as the answer. I hope this is very clear. This was a good question. We move on to the next. The next question reads, a student walks to school at the rate of 2.5 kmph and reaches 6 minutes too late. Next day, he increases his speed by 2 kmph and then reaches the school 10 minutes early. Good, he has learned his lessons well. The distance of the school from his home is, and we are given 4 options. Here is the solution. To solve this question, it is important to understand that the distance is fixed. I hope this is very clear to you. The distance from his home to school is fixed. And we know very well that distance is speed into time. Let us say the usual time that the student takes to reach the school is t. So now our equation would be d is equal to speed, which is 2.5, into, when he goes at 2.5, he is 6 minutes late. 6 minutes is 1 by 10 hours. So t plus 1 by 10, because we are taking t in hours and speed in kmph. But distance also is speed, which is 2, into the next day he reaches 10 minutes early. Good. Now what happens the next day? The next day he increases his speed by 2 kmph. So now the distance is fixed. 2.5 goes up by 2, becomes 4.5, and he takes 10 minutes less. So that will be t minus 1 by 6, because 10 minutes is 1/6 of an hour. All we have to do is compare these two equations now. And when I compare and solve these two equations, I can easily get the value of t, which will be 1 by 2 hours. But that is not the question. The question is, what is the distance? So all I need to do is substitute the value of t in either this or this. So let us substitute this in the first equation and we get d will be equal to, this has moved down, let me take it slightly up. D will be equal to 2.5 into 1 by 2 plus 1 by 10. So that will be 2.5 into 6 by 10, and that gives me the value of d finally as 1.5 kilometers, which in our option was option number 1. This is the answer. I hope the solution is absolutely clear to you. A very, very elegant and simple solution based on fixed distance. Okay, so let's move on to the next one. The next question. A cyclist starts from Delhi towards Gurgaon, which is 100 kilometers away. He is able to maintain a speed of 20 kmph in the first hour, after which his speed falls to 18 kmph. He is able to maintain this speed for the next hour, after which it falls to 16.2 kmph, which also he maintains for an hour. In the fourth hour, he is able to maintain a speed of 14.58 kmph and so on. How much time approximately does it take to reach Gurgaon? And we are given 4 options. Here is the solution. You will have to observe the speeds carefully. Let us write down the speeds. 20 becomes 18, becomes 16.2, becomes 14.58. This is the first hour, this is the second hour, this is the third hour, this is the fourth hour, and so on. And the question is, when does he reach Gurgaon? 20 and 18. As you can see clearly, 20 multiplied by 0.9 will be 18. 18 and 16.2, there is a difference of 1.8. It is very obvious 18 into 0.9 will be 16.2. So the clue we get is that the speeds are decreasing consistently by 10%. Or this is the GP with 0.9 as the reducing ratio. 16.2 into 0.9 again gives you 1.62 less, which is 14.58. And so what we have to now do is, we have to keep on adding till we get a sum of 100, and then we have to get the exact answer. So let us see, let us try to do that. 14.58 into 0.9 gives me 14.58 less 1.458. That gives me 13.122. Again, let me reduce this by, this was the fifth hour actually. Again, let me reduce 13.12 by 0.9. That gives me 11.81. This is the sixth hour. But if I add up, I have not reached 100 so far because I haven't. Again, I reduce this by 10%, 11.81 into 0.9. That will give me around 10.63 and so on. But if I add, I can see that I have crossed 100 by now. At the end of the sixth hour, the cumulative distances traveled, you can make a table on this side also. You can add up here. This will be 30, 8 here, 20 plus 18, that would be 38. So I add this further, I'll get 54.2. I add this, I get 68.78, 81.9, 93.71. And here, bingo, we have crossed this. So it is obvious that Gurgaon was reached in the middle somewhere here. So after the sixth hour, and that is obvious because all the four options also tell us the same thing. But here, after the sixth hour, the speed is 10.63 kilometers per hour. We are moving at this particular pace, and 6 hours are gone. And we are left with 100 minus 93.71. So at the speed of 10.63 kmph, we have to now cover the remaining distance. If you calculate it, that value will come to be around 36 minutes. That is our answer. So this is a slightly clerical question because values had to be added up, but there is no other way of solving it. An approximation cannot work here because all other options are also 6 hours and something. Had it been 5 hours or 7 hours, then the only option with 6 hours would have been correct. But here you will have to actually calculate that once you are at 93.71, then the balance distance that you have to cover, which is 6.29 kilometers at a speed of 10.63, will take 36 minutes. I hope this is absolutely clear. We move on to the next question. Okay, the question reads, A and B start at the same time from L and M to go to M and L, a distance of 42 kilometers. Their speeds are 4 and 3 kmph respectively. They meet at a point N, then go to M and L, and return and meet at D. Find the distance Dn. Here is the solution. This is L and this is M. A is starting from here and B is starting from here. The total distance is given to us as 42 kilometers. He says that their speeds are 4 and 3. First, they meet at N. Let us say this is N. Now I have drawn N slightly closer to M because A is faster. They have met at N, then they reach M and L and return and meet at D. Let us say this is D. So the question is, what is the value of dn? dn is to be found. This is the question. Not too difficult. Let's get cracking. When they meet for the first time, we will have to remember that the total distance traveled is equal to ln plus mn, which is actually the whole distance, 42. Then they go to M and L. So that means they again cover a distance of how much? 42. And then they return and meet at D. So that means they have again covered a distance of how much? 42. So that means when they meet at D, the distance traveled by both of them together has been 42 plus 42 plus 42. We have just seen that. And the total distance they have traveled has actually become equal to 126 kilometers. So I hope this is very clear. Now, so when A meets B at N, the times they have taken to travel are the same, and we know by the basic principle that when the time taken is the same, then the distance is covered very directly as the speed. And so that means the distance covered by A when he meets B for the first time at N will be 4 upon 4 plus 3. This is the ratio of their speeds, 4 and 3. 4 upon 4 plus 3 into 42. Total distance has been broken down into these two quantities. So the distance traveled by A, which is actually equal to ln, is given by this equation, 4 by 7 into 42, which is 4 into 6, which is 4 by 7 into 42, which is ln, and which comes out to be equal to 24. So ln is 24. The moment we know that ln is 24, we know the value of mn. Perhaps we may not need it. When B meets A at D, the total distance traveled by B till that time, we know that together they have covered 126. So how much would B have covered when he meets A for the first time at D? Ratio of their speeds, 3 upon 4 plus 3 into 126. So this gives you 54 kilometers. But we know very well that this 54 kilometers, which is the distance traveled by B, is actually equal to ml plus ld. But ml is already known to us, which is 42. So this means that the value of ld is now known, and ld is 54 minus 42, which is equal to 12 kilometers. So ld is known to us, which is 12. If you look at this diagram here, we have just found out ld, which is 12. But remember, we had already found out the value of ln, the distance traveled by A when he met B for the first time, which was 24. So the difference is 12, which is what we had to find out. And the answer is 12, which is option 2. I hope this solution is very clear to you. This is how we have solved it using the first principles. And the final answer is option 2, which is 12. So that, my dear friend, was the complete session on time, speed and distance. I hope you enjoyed it. Revise it thoroughly, get your concepts in place and try to solve questions mentally wherever possible. I wish you all the best in application of whatever you have learned. All the best.